afternoon, all, and welcome to the Forum of Women Who Code Connect Conference 2022. So now there will be a session commencing about next-gen security using artificial intelligence. I'll be introducing the speakers for the session, Ranjani Swaminathan and Ramya Victor. Ramya has 9+ years of experience in the software industry in the domain of network and storage. She has a master's degree in software engineering and PG diploma in AI/ML and cloud computing. She is an active innovator and has presented in various national and international conferences like Open Summit, Grace Hopper Celebrations India, and VMware, meetups, etc. She actively presents sessions on AI/ML, cloud, and virtualization across different communities and colleges. She is the City Director of Women Who Code Bangalore and also GSCI committee member of AI/ML. She is passionate in dramatics and voracious reader. Welcome, Ramya, and happy to have you here.
Thank you, Pushpa, for that wonderful, warm invitation.
Yeah. So, introducing next speaker, Ranjani. She is an engineering manager in VMware with 13+ years of experience. She has participated and won in various industry-wide hackathons on blockchain and machine learning. She has been a speaker in external conferences like Gino and Women Who Code Connect Asia 2019. Rajni is one of the city director of Women Who Code Bangalore and also committee member in GSC India of AI/ML. Welcome, Rajni, and happy to have you here. The stage is yours. Thank you.
Thanks, Pushpa, for those warm notes. And hi all, I am Ranjani Swaminathan, and I am passionate about finding some problems that can be solved with machine learning and trying to find out some solutions also. So, Ramya, would you share your screen with the slides?
Yeah, Ranjani, I'm just trying to do that.
So while Ramya is sharing, so one such area where we see that ML can potentially be used for solving problems is the cyber security. So what does cyber security mean? Cyber means the ocean of network that we have added all our devices to. And we see that there is a control that a owner can have, and similar control can be tried upon by the hackers also on this network of devices which are exposed to the internet. So that is where we see that the devices are in a risk of being hacked. That is why we need cyber security, which is securing our devices and be it smart appliances that are related to our home or enterprise appliances like all our servers and data and information, anything that is available from the hackers who are looking forward for getting malicious access to the data and information and trying to make money out of it. So that is about cyber security, where we try to secure all the data, content, and the devices which are out in the internet. So why do we even need machine learning in cyber security? As I mentioned, the data which is present is humongous, and we connect all our devices to the network, and there are logs and traces that are created by all these devices. Those are also piling up in the storage that is available in the network. And the data is humongous, and for processing such data, we would need a lot of high performance computers, and if we do it manually, it will be a erroneous process and a tedious process also. So that is where machine learning can help us do some of these work, like when you have fed up data into the machine learning model, it can help you analyze with all the visualization techniques available in some of the Python libraries, and so that you can get some insights into what has been happening around in the network logs that we have attained. So we still have challenges with projecting, is it?
Ye-
Let me try
Yeah,
to.
looks like that, Ranjini. Can you try to project it yourself? Okay.
Where I had talked about the need for having AI/ML for solving some of these cybersecurity issues. So we see that the data which is available is humongous, and we see that there are lot of cyber crime activities which are happening for making money. And we see that most of our systems that are available to place these guardrails are pattern based, in the sense that whenever there has been some such attacks that are happened in the past, that have been noted, and it is present in the database. If there is a new packet that arrives and it has similarities between the ones that we have already labeled as attacks, only then we will be able to classify these attacks in the current time. So it means that it is supervised, and the type of attack should be known to the system previously. So there will be various attacks that are getting evolved. As we keep on evolving our guardrails to prevent these attacks, the hackers are evolving their techniques of attacking these systems. So those new types of attacks which the system is unaware of gets tedious to be identified on the day zero. When it is getting attacked for the first time, we would not be able to find out or classify such attacks. So that is why we would need anomaly detections or neural networks and unsupervised learning to help in classifying such day zero attacks also, and the new types of attacks also. So in these challenges, ML will be able to help us get forth these and try to figure out attacks and take preventive measures in case of such attacks. So that is why we would need AI/ML in cybersecurity.
So while Ranjini is sharing that, right, we all know there's like huge amount of data in the world that is kind of available for anyone to look at and process, right? So since we understand the need of cybersecurity protection and how AI/ML can kind of help in that, let us first understand the core essence of why hackers are behind information, right? See, why information is so essential for any hackers, because information gives a lot of valuable data for the hackers. With the information, the hacker can get data which might give a competitive advantage to the opposite company. Say, for example, a company X and a company Y are developing the same product which is related to a specific security protection. And suppose they need a well defined data in order to test their product. In case they get a good foothold of the data that is being used as a baseline by, say, the company Y, then the company X can kind of make its product much more better than the company Y, right? But how can it get the data? It cannot just easily go and ask the company Y to give the data, right? So that is when a kind of an unethical ways you go through an hacker. I'm not telling that everyone does this. This is a hypothetical example where the company X gets the data of company Y through hackers. So the hackers are playing a very prominent role over here because they are the people who are kind of getting the valuable information, because the information that they obtain is a critical information, which is also sensitive and valuable information in terms of competitive advantage. So that's why when you see in cyber security, there is a huge demand for this cyber security crime, especially because the data that is obtained is huge value to anyone who is working in a specific domain. So that's why there is a hunger or a thirst to kind of get the data that is of good advantage to the opposition. So once we know the core essence of why cyber security has come into picture, because we need to protect this data from such hackers, right? Let us move on to the types of attacks. Ranjini, would you mind sharing the types of attacks slide, please? That's the next slide. Yeah, so here we have listed few of the types of attack that we will be dwelling in our data set today. So some of the attacks to name are here is fuzzer. So in fuzzer, what happens is that the attacker attempts to kind of uncover the security loopholes that kind of exist in a particular operating system or a particular software that you have developed by feeding it a massive random data. Okay, so that the operating system or the program kind of, if it has any loophole, it kind of succumbs to such huge amount of data that is fed into it. And another such type of attack is an analysis. It's a type of intrusion that kind of penetrates the web application through various ports. So we know there are multiple ports for any program that you take, say 80, say 443, that is HTTP and HTTPS ports. So there are multiple other ports. So you can kind of induce attacks by penetrating through such ports. Okay, so that type of attack is called analysis. Another one is an exploit. So here what happens is a sequence of instructions are used to exploit a vulnerability in a particular program using the network. So that is one type of attack. Then you have another thing called the worm. We all must have heard about it. So here what happens is that in this attack, there is a malicious script which kind of replicates itself in a random fashion and in a very fast speed across the computer, thereby bringing that particular security in that system down, and thereby it gets access to the sensitive and valuable data. Another very common attack that most of the folks in networking would have seen is the DOS attack. So here what happens is that an intrusion disrupts the computer resource. It's often through the memory, or it can be also through an unauthorized request for accessing a device. So these are some of the common attacks that generally you would see when we talk about cyber security. So in our data set today, we will be kind of touch basing on few of these data sets. So Ranjani, would you mind moving to the data set slide, please? Yeah. So in today's data set that we are going to run through in our Jupyter notebook, we will be seeing a few of the attacks that I just mentioned about. So in our data set, we have around 11 features, we would say. So in this 11 features, we have just taken a screenshot over here just to show you how it looks. The first category is nothing but your attack category that I just kind of touch based upon. And if you see, whenever you talk about network attacks, right, generally the concept of port comes into picture. So we know any network has multiple ports through which you can access multiple protocols, right? Each protocol has a particular port associated with it through which you establish your communication. This is what we have generally studied in our networking in the OSI model, right? So here we are categorizing the attacks based on the source IP because we want the source which has initiated the attack, and the destination IP because we want to know the victim of this attack. So when we are talking about attack over the network, as I mentioned, we need to know the port. So we have the source port, destination port, and here we have over which kind of protocol the attack was made, whether it is TCP or UDP. And here we have also have the information upon the attack type. So what kind of attack was made. So attack category is a different concept and the attack type is a different concept. So we have addressed that as well. So this is a brief overview of how the data set looks like. Now we'll go into the Jupyter note and see the more details about it. Ranjani, would you mind sharing the Jupyter note, please? Hey, Ranjani.
Yeah, I
Yeah,
am.
sure.
Yeah,
Yeah.
I am able to
Okay.
share a Chrome tab, but not a Safari. Give me 1 minute.
Yeah, sure. No problem, Ranjani. So while Ranjani is sharing the data set, right, let me kind of set the business context over here. So here we are taking a case study. So the case study is that there is a cyber security expert in a company who has obtained the data from past 6 months. So when I tell data, it is basically the network logs that have been obtained. So using that network log, he or she is going to look into each of these logs and try to understand if there is any pattern which kind of we can derive from this, and kind of make sure that future such attacks can be prevented. So that is just to give you a gist of what is the scope and business context over here. So in order to do that, we will be using the basic libraries that are available in any machine learning projects. So that is basically pandas. So if you would have worked upon machine learning projects earlier, you know that we will be dealing with the data set that is either in a CSV or in a text file. So whenever we are having the data in this raw format, we want to kind of structure it into a data frame because it becomes easy for machine learning, any of the libraries, to process the data in a much efficient manner when it is structured inside a data frame. So that's why we would be using pandas, which kind of is used to convert the data which is in any of the raw formats like the CSV or text into a data frame. And then the other library that we'll be using in our notebook today is Seaborn. Seaborn is basically used to give you a better pictorial representation of your data. Another one is the matplotlib. We all would have used matplotlib somewhere down the line if you have worked on AI ML. That is also used for plotting. Excuse me. And another thing, very important model that we'll be using is called missing no. See, generally when we are dealing with any data set, right, we need to understand what are the missing values in that data set. This missing no is a wonderful kind of library which shows you in a pictorial format what are the missing values, which are the attributes that are having missing values. Rather than doing a normal data frame is equal to null, we could kind of use this missing no library, which is very useful to understand that. So if we will be sharing this notebook at the end of this session, so you could kind of use that and try whatever we are trying today. So Ranjini, we are good to start?
Yeah.
Okay, thank you, Ranjini. So Ranjini, could you just kind of go to the import statements which I just covered? Yeah, sure. Yeah, thank you, Ranjini. Just keep it over there. Yeah, so now if you see that, so Ranjini, I'll be just going through, you can kind of scroll based on what I'm speaking. Is that fine?
Yeah.
Yeah, so if you see our data set name is cybersecurity_attacks.csv. So this is the data set that we have. This data set, we will be uploading it. We have obtained from one of the Google resources. We'll be sharing that as well. So if you see that we are just reading a CSV and converting it into data frame using pandas, which I just mentioned. So in this data frame, there are around 1,78,031 rows. So many data we have, and we have 11 attributes. Okay, 11 attributes. When I say, these are just the features that we have considered for our understanding of the particular use case. So here the different columns are listed over here. If you see in this data frame, the column names are attack category, attack subcategory, pretty much the ones that I just described. So and then we are just doing a data frame.h. So the data frame.h kind of lists all the different features that we have considered. Okay, so now what we observe over here is in the last column, you can see time, right? So the time is kind of a cumulative time, which kind of has the start time and end time. So here it would be interesting to kind of split that time into a start time and end time rather than considering the entire time as is. So that's why what we have done in the next step is that we have split that time, which is a single attribute over here, which has the both start time and end time as separate columns. Like we have a start time and then the end time. That's what is the code over here. You can see df of start time comma last time. That one we are populating by using the existing time attribute. We are just here, if you see the start time and end time are separated by a hyphen, we are just using a string split normal manipulation command over here. And then we are kind of listing the columns and seeing. So when we list the column and see, right, Ranjani, can you highlight the dot over there? There is an additional attribute called dot, which doesn't kind of give us any relevant data. So we want to remove that column. So we are using a drop command here. So if you just do a drop command, that particular attribute is gone, right? So we are just dropping that particular attribute and giving access equal to 1 because we want to drop a column over there. So now if you see df.shape, right, you can still see 11 as the attribute, because what we basically did, we dropped the dot column, we dropped the time, but instead now since we dropped 2, we have added 2, that is the start time and last time. So the number of attributes still remains 11. So now this is the interesting part which I just spoke about, right? Whenever yeah, Ranjani, down only. So whenever we want to see if any of the attributes have some nan values or some missing values, no values at all, we generally have a function over there where we have to see like pd as in a data frame, whether data frame is equal to null, and we pass the attribute name. This is another interesting library that you can use, which pictorially shows, which are the missing values. So here, if you see, missing no is the library name. So we have constructed two particular pictorial representation. One is the matrix, which is on your left side, the blue one. Another one is a bar graph, okay, which will just show you how many values are there, right? We all saw that there's 1,78,031 values, right? So in the left side, if you see the matrix, right, in the matrix, you can see the second column, right, the attack subcategory. The white lines are nothing but which clearly shows that that particular row doesn't have value for attack subcategory, right? So all the white lines that you can see in that particular column, right, these white lines indicate that there is no value for that particular row in that particular column. So the same thing, if you see attack reference has so many rows which doesn't have those values, right? So this is a very pictorial way to understand which are the features which do not have value. So and then you have another one, right side you have another image. So this image is nothing but your bar graph, which clearly shows that how many values are present here. If you see the second row, right, second row has less values here because it few of the entries are not there. And the last column that we saw, attack reference, there a number of values are not present. So this is a very nice library, you can explore in other projects as well. So after we are done with that, moving on, we are trying to go and see what more discrepancies are there in our data set so that we can use it to process it in a better way. So then what we are seeing is we are going and checking whatever we saw now in a pictorial format in a script format. We are just doing df is null.sum. So which clearly shows that attack subcategories and attack references are having some null values. So that is the number 4192 and 51745. Okay, so now what we can do now is that, see, we whenever there is a null value or a value that is not relevant to our data set, right, we or an empty value, we usually do impute. Impute is nothing but you try to put in some value over there which is relevant in that. Since here we are dealing with kind of cybersecurity related data, it doesn't make sense to kind of randomly fill some value over there, right, for attack subcategory, because all the other, each attack is of different type. You cannot just randomly put some attack for that row because it doesn't have an attack subcategory, right? So what we are doing is we are just filling wherever there is no value for the attack subcategory, we are just filling it with not registered. So here we, if you see in the line, we are filling it with not registered. And then we are just again doing df is null to check that whether all the null values are being filled with not registered. So here you can see attack subcategory has 0 null values. So then we are looking good with this, right? So now what we are doing is, if you move a little bit down, we are trying to see if there are some duplicate values that we don't want to consider, right? Because since we are anyway processing with data, if there are some duplicate rows, it doesn't make sense to consider those rows again and again, right? So here we are using df.duplicated. It's a simple method, built-in method, and we are seeing how many are duplicate. We found that 6 rows are duplicate. So we are kind of what we are telling, we don't want to consider those duplicates. So we are kind of eliminating those duplicates over there. Okay. So then if you go to the next, yeah, if you go to the next line, we have the port range. So any networking person might clearly understand that the port range is always from 0 to 65535. Okay, so since we are analyzing the network data, right, we need to make sure that the data are valid and accurate. So here what we are doing is we are doing a validity check to ensure that the port group lies only between 0 to 65535. If there are any port group values which is below 0 or greater than 65535, doesn't make sense to process that data over here, right? So that is what we are doing in the next step. We are kind of filtering out all the rows which have the invalid destination port or the source port. So then after we are doing that, we see the df dot shape, it has kind of slightly reduced because we have cleaned up certain unrelevant data over here. Next, what we are doing is we are doing a simple textual cleaning over here. Here, if you see the different type of attack categories listed, right? The protocols basically. You can see TCP, UDP. Then in again you see TCP, UDP. Few of them are in lowercase, few of them are in uppercase. In few words, T is capital. So there is some discrepancies in the way the textual data is written, right? So all data represents the same, but it is just that the format is not as we expected. So what we are trying to do here is we are trying to kind of make all of them into uppercase. And if you see even the attacks categories that I just discovered, sorry for the slattering here. Yeah, the attack categories that we just described, right, where the exploit, backdoor. So here also, if you see, right, there is one with backdoor, another one with just backdoor. So one is kind of ended with S, backdoors. Another one is just backdoor. It's all naming conventions. And the reconsonance is there 3 times. One has a space before, one has a space after. So it's all about the string manipulation, right? The meaning of the word is same, but the words are represented in different format. So the better way to deal with this is to convert all of them to upper category and strip them of extra space beginning and after. So that's what we are doing in the next text box, if you see, we are converting all to uppercase and stripping them of the extra space before and after them. So then if you see, we are good. And when we list it, right, we kind of see a more clean data over here. So that's what we see in this particular reference. So once we see all this data, right, we are kind of in a good state to start the processing. Okay, the subsequent cells are just seeing the unique value counts across each of this particular attack categories and attack subcategories. And what we are trying to do in the subsequent columns is that we are trying to see if there is any particular attack which is of very less value. So if you see here, probably Ranjani, you're showing down, right? Yeah, there is a very less value over there, right? So those kind of attacks which have very less data, what happens is data becomes skewed. Ranjani touched based on this, right? So whenever we have a real world data, it is not necessary that the data that we have is pretty well categorized across all the attack types. So the
So these
fuzzer has more
percentages
data.
may help.
Yeah, yeah, exactly. So if you can kind of keep this percentage, the ones which have very less percentage of data, you can kind of not consider it when you're processing your data. So you can consider the ones which have very good amount of rows, right? So that's what we are kind of putting it over there, so that we can consider only the rows that have good distribution of data. Means we have around 88% in fuzzer attack, so many number of rows. So we can use those so that our model is not very biased towards only the high value one. Rather, we have a data which has equal distribution across all. So that's what we are doing in all this particular row computations below. Yeah. So Ranjini, you want to go ahead and continue?
Yeah, sure. Thanks,
Yeah.
Ramya. So what we have done so far is the pre-processing of data. So as I mentioned, there are many challenges when we are using ML in attaining these cyber security problems, right? So one of the things that I mentioned is about the pre-processing. It is very important to understand what the data actually means and what is required for us and what is unnecessary data. Because whenever you feed any data into the model, it should be the model cannot separate out the data as useful data or useless data. So that part has to be done manually by us, the data scientists. So I think all these things whichever has been done till now is the pre-processing of data, cleaning up of data and making it usable by our Python libraries to showcase like visually or interpret data in a way which is accurate. So we have done all these pre-processing. Now what we are going to do is, we know that there are some TCP ports and descriptions for them. What we are going to do is, we will now merge all these TCP ports numbers with the service description. So instead of telling that 80, we'll say that it is the HTTP port. And instead of telling 443, we'll say what the use of that port is, telling that it is the HTTPS protocol. And all those things we will try, and we will merge these data frames to arrive at our new data frame, which is having details like the source port, the destination port, and what is the destination port service. As I mentioned, if it is HTTP, if it is 80, the destination port, then it is a HTTP service port. Those details we have merged into this data set. So then what we are seeing is the number of unique values which are there for the attack subcategory. So we see that reconnaissance, exploits, as Ramya explained, these are some of the unique values that are present as attack categories. And then she also mentioned about a lean data which is present for some kind of attack categories, whereas we have dense data for some of the attack categories. So this visualizing this, we see that exploits we have around 70,000 rows. Fuzzers we have these many, but in backdoor analysis and shell code we have lesser number of data. So it may lead to a bias in our machine learning algorithms, telling that our machine learning algorithm has seen exploits more. So any data that comes into the any test data that comes, or any actual data that we want to classify may be more biased and put towards the exploit. So what we should do is we should try to normalize this data so that our machine learning algorithm doesn't have this problem of bias. So now what we will do is we will take only those which are having more data, so that we will clean up all the other attack categories which has less count, and then proceed with our analysis. So the first thing that we are doing here is to see that we are seeing it in a pie chart, telling that most of the data which is available is tending towards exploits, and the next large amount of data we have is for the fuzzers type of attack category. So similarly, we can visualize and see that this is the highest present category, and followed by the ones that are getting leaner in number when we are trying to visualize the data. So now that we have seen what the data is like, and we know how much data is present, let us go on analyzing data based on various parameters. The first one that we would take is how to analyze these attacks with date and time. So as Ramya mentioned, we had taken the start time and the end time from the duration value, and we already have this start time, end time, and we are calculating one metric, which is the duration of the request. So there will be various attackers who are trying to send requests to various ports for a different duration. For example, if an attacker sends a request to port 80, but he is aware that this port is open, now what he does is he then sends many requests which may try to create a denial of service or any other malicious attack. So what happens is the duration for which he holds this port, or from a destination port, the duration for which the attacker sends requests will be more. So we see that 80 is open, and so the duration of requests is taking more. And there may be these ports which are not open, and so the duration of the attack may be less. So we are trying to find out similar instances where we can derive insights based on what we have, based on the data we have, on what is the time at which they are making these attacks and what is the duration for which they are making these attacks. So we see from here that we have calculated the duration, and now what we do is we will stick to some time range. Because the time range is vast, we are now trying to reduce the time range on which we are making these, doing this visualization. So in this case, what we have done is we are taking 2 days, and based on that 2 days, we are going to see what our data looks like. So we see that on these 2 days, the source port which have been sent requests from are ranging from 1,74,000 is the count that we have, and what is the maximum and min values that are present. So the min value is 0 and the maximum value is 65535. That is the range in which a port can have values from. So that is proper in both the source and destination ports, as we have already cleaned the data. But we see that the 75th percentile, which means that 75% of your data falls within this value for the port numbers that are being attacked. So for example, the source port is being 31,862, the 75th percentile, but the destination port 75th percentile is 80. So that means that there is a vast difference between the source port range and the destination port range. So this is what we have got from this data. So as a human being, you are able to come to a conclusion that there is a wide difference between the destination port and the source port ranges. Now what we see is we have a way to confirm our hypothesis. So we'll have to test our hypothesis. Our hypothesis is that there is a vast change or range difference between this destination port range and the source port range. So we have a method which helps in testing out our hypothesis. So we know that we have some p-value which will say that if the p-value that is got based on these two parameters is kind of more than 0.05, then we say that our hypothesis is proper. If it is less than 0.05, we say that our hypothesis is wrong, and we take the opposite of our hypothesis that we had concluded. So now we see that from the p-value, we say that null hypothesis is usually a positive scenario. So in our case, whatever we have taken as null hypothesis is that there is no much change between the range values. Okay, I think I told it wrong in the previous case. The null hypothesis will always be a positive case. Okay, so now we have assumed that the difference between the source port and destination port is not varying too much, and so and we have used this method to find out if our hypothesis is correct. So we have got a value, p-value, which is much less than the value that we are expecting, the alpha value, which is 0.05. So which means that whatever our null hypothesis that we have considered is not proper, and now we take the opposite of it, telling that there is a wide range of difference, and we may need to analyze it more, so that the attackers are making web requests at the ports which are lower in number, like the ports from 0 to 125 have been attacked more, whereas the higher range ports are being attacked less. So that is one conclusion that we can get from the p-value test that we have done so far. So the next one, then we will have to try to find out if there are any correlation between all these parameters that we have seen. So that so we have various parameters, right? So we'll have to check how our attack category and attack subcategory, which are the results, are affected by source IP or protocol or source port or destination port. For example, if there is a correlation between the destination port and the attack category, it means that as we found out that the lower ports are attacked more, so there should be a correlation between the destination port and the attack subcategory. So that we will find out by using this correlation method, and we will find out if there is a linear or monotonic correlation between these features. So what we are going to do is, now we have done this correlation, and we have this we have the data frame with the correlation values, where we will do a Pearson correlation, which will say whether there is a linear relationship between the two features that we are comparing. For example, there we see that the correlation values are 1, which is the highest, for 1 for the source port and source port, which is the same value. So we have the highest correlation for these two. So then we have destination port and source port, for which we see that the value is 0.13715. So it means that there is some correlation between, linear correlation between the source port and destination. And then there is duration and source port, where we see that the correlation value is negative. It means that there is no correlation between these two values. So that is how we calculate the correlation between the features based on this Pearson method. So it will show only if there is a linear relationship between these two parameters. For example, if there is a pattern which says when destination port is more, is the duration getting more or duration getting less? If there is a kind of linear correlation, only those will be found out by this Pearson method. We also have the Spearman method of correlation, where we find monotonic relationships. Like it may not be linear. So whenever source port increases, is the duration getting increased, or when the source port is of a higher number, is the duration getting decreased? That linear relationship will not be there. Though there may be monotonic relationship, like some kind of a curve or something, which will still be having some correlation, but not a linear correlation. So that we will find out with this Spearman correlation. So when we have done the Spearman correlation, we see that this destination port and the duration has some correlation, and so what we will do is we will try to visualize that. So for visualizing, we are using this heat map method. So from the correlation values, as I said, this is the Pearson correlation, which shows that there are not much correlation. So if you see this graph, whenever there are dark colored regions, those are more correlated, and whenever there are light colors, those doesn't have any correlation. Those features doesn't have any correlation. So on the left on the y-axis, we see that there are source port, destination port, and other features. And similarly, we have this 2x2 matrix where source port, destination port are also present in the columns. So we'll see that there are not much correlations in the Pearson. Whereas if we do this visualization for Spearman correlation, we see that there are destination port, source port, and we have this duration with the source port and destination port, which are having higher correlation values. So now, taking this into account, we will delve into details of like doing a pair plot with these two values only. So for example, we'll take duration and source port and do a pair plot, which says that whenever you have the source port in these ranges, we see that there is the duration of the request is more. It means that when the source port is low, for example here, so you see that it is between 0 and 100 odd. We see that there are a lot of requests sent, and it has been sent for a longer duration. For the destination port, it is scattered. So there is no specific outcomes that we can derive from this scattered plot, scattered graph. So we should have something which is overlapping and thick at one region to find out if there is a stronger correlation and if there is a causal or any relationship between those features. Now what we will do is, we see that there are several destination IPs for which the number of requests, the destination IPs which are targeted for sending requests. So we see that 149.171, this IP has got multiple requests, and which is more, for 43,000 requests are sent for this IP. So what we will do is, we will now take a particular IP and see how how attacks are being done to this destination IP and the destination ports. So we see that for this particular IP, if we have taken and then we are analyzing, we see that towards the left region, or the two dates that we see are disconnected, right? So we'll take this date separately and do a scatter plot to understand how attacks have been done on this date, and this date we'll take separately and analyze for attacks. So first we are taking the left region, and in the left region we see that whenever there are port ranges which are there from 0 to maybe here it is something around 100, we see that there are multiple attacks which are tried over this port ranges. When the port range is low, the attack is more. And as the port range goes up, when the port is 20,000, 30,000 odd, we see that the number of attacks is less. So it means that they know that in this specific destination, the lower port range, maybe something from 0 to 100, are opened, and they are trying to attack this specific port range. The attackers are trying to take advantage of the lower ports which are open, and they have seen that there is no use attacking the higher ports. Maybe they have tried once or twice, but it is closed and it is not and then they see that there is no reason to attack the higher ports. So this is one analysis that we have done, and tried to correlate the port ranges and the number of attacks that have happened. So then we see that this is the scatter plot for the right side of the graph. So here also we see that there is a dense attack which is happening at the lower port ranges. So on a different date also it has been the same, that they are trying to attack the lower port ranges. So then we see, we will be able to check with this scatter plot again to see what type of attacks are happening. So if we see in the port 80, we see that various types of attacks are happening. It is not confined to only exploits or reconnaissance or generic. So we see that multiple types of attacks are happening on the port 80. So that can also be visualized with the plots that we have. And then we are trying to see what the duration versus destination ports are. So we see that when the destination port is low, we see that the attacks have lasted for a higher duration. We see that it has lasted to at least 60 minutes, or when the port range is low. So this can also be viewed from the plot that we are doing. So what else will we be interested in is this violin plot, which says whenever, this is also one way of visualizing how different attacks and different durations are the correlation between the different types of attacks and duration to which it has lasted. So now we see that the other for reconnaissance or exploits or DDoS, we see that the plot is standard, and only for this shellcode attack subcategory, we see that the plot is different, and it has different kind of graph in the shellcode attack category. So what we see is we are confining it to one time range. So to say that, is there any correlation between the time at which the attacks are happening? So there we are from our data set, we have taken the start time or end time, and we have just tried to take the hour of the day. That is what we have done. Now we have taken the hour of the day as a separate field, and we are going to make our analysis based on the hour of the day. So we see that we have data which is spanning from maybe morning 12 to afternoon 1 o'clock. So we are now going to visualize and try to find out some insights from based on the hour of attack. So we see that this is again a heat map which has the hour on the left on the y-axis, the type of attack on the x-axis, and the colors will mean the duration of attack. So when we see here, there are we see that the shell code and worms, we we see that these types of attacks have not gone beyond 2000. But we see that there are some attacks like exploits and DDoS attacks, which are more at certain points in the certain hour of the day. So, for example, at odd hour of the day, we see that the attacks are lasting for a longer duration. So, from this, we can get some insights to see if in this particular company, if the employees are working on the odd hour, or if they are taking break at the odd hour, and similar such insights can be derived from this. Also, we see that at a particular hour of the day, there are more attacks that are happening using exploits and DDoS. When I mentioned DDoS, there may be specific time in the company where backups are done, so people can try to prevent that. In that case, they will try to do attacks only on the specific hours where they have recognized some patterns within that company. So from
Hey,
this
Ranjani, in
also,
the benefit of time, sorry to break you, can we kind of move towards the end conclusion, Ranjani? I think we are on time. On time. We just are.
yeah, we will
It's
have
3:30.
only one or two more steps to see the
Sure.
correlation and understand how from the data we can also try to find patterns and devise some preventive measures. So as I mentioned, in this also we see that backdoor attacks are lasting for a longer duration at 1 a.m. So as I mentioned, there may be some patterns that are known by the attackers, and based on that, they are trying to do this attack, backdoor attacks, only at 1 a.m. daily, or at 1 a.m. usually. So this shows that the attacker also knows some pattern, so that the companies can use this to devise any understand the patterns and try to prevent these attacks. So from here also we see that there are certain hours of the day where certain attacks are being done vigorously. So this correlation helps us in finding out some of these correlation between the features, and try to devise some plans to avoid these. So yeah, so I think we have given some details about how to use the data set, how to clean it, and how to find correlation between various features within the data set, and how to interpret those results in terms of security. And as we have done this, we would be able to then devise some plans and feed it into machine learning models, maybe to find the incoming traffic, whether it is an attack or it is a legitimate request. So those can be taken up by the participants in their own interest, but this would give a basic understanding of how machine learning can be used in cybersecurity. If there are any questions, we are ready to take on this.
I think, there are no questions. Yeah,
So
it's a
yeah, I
wonderful.
see that there is a question that we are not using any models here. Yeah, so all the supervised learning and unsupervised learning models can be are the basic ones that everybody will know. But how to apply it to a specific data set and to a specific domain of the industry is what we have focused on. So that we have done all the data analysis that to see how it has been correlated, and how it affects the actual data using the network logs which were present, the data set which we have got. So the next steps, as you mentioned, applying models and predicting or classifying the incoming data can be taken up by participants. with any available
Yeah.
machine learning models.
Yeah, just to add on to Ranjani, right? The data processing is a very critical step. Understanding useful data from your existing data set is very challenging, right? If that step is done, invoking any machine learning model is just a one-line call because we mostly have most of the modules available, isn't it, Ranjani? So that's
Yeah.
why we wanted to touch base on understanding the data, trying to get patterns from that itself, because understanding data itself will solve most of the problems for us most of the time. We don't have to go to a model to solve the issues. Getting it? The
And
whole essence of machine learning is that try to understand data and then you use machine learning only when it is actually needed, right? So we wanted to give that gist for you, and then you can apply any model on this data set. That is, as Ranjini said. Go ahead, Ranjini, you were telling
And
something.
this is a new thing where you can use machine learning for how to use machine learning with cyber security, and what type of insights you can get, and what type of preventive measures you can do. Like, I have not listed down any preventive measures, but insights that we get from a cyber security related data is can help all our security experts in trying to shut down most of the areas where hackers are looking for. So we wanted to have a flavor of the machine learning in cybersecurity introduced to the participants so that they can try out various algorithms later.
Yeah. So if there are any questions, feel free to ping in the event chats. We will be there. We can monitor that as well. You can reach out to us in our LinkedIn profile, so you can find our name, and feel free to reach out to us. And if we are able to answer you, we definitely try to do.
Thank you all for being a good audience and posting questions.
Yeah, thank you. Thanks everyone for attending our session. We really appreciate your time and hope you got to learn something useful and explore more in this particular domain. Thank you.
Yeah, it's a wonderful session, Ranjani and Ramya, about next generation endpoint security uses modern artificial intelligence, machine learning to provide endpoint security solutions. Thank you, Ranjani and Ramya. Audience, please stay tuned for the next session.
Thank you, Pushpa.